we graph them. You guys all know that quadratics are up like a cup or down like a frown. We know that. We know that through the quadratics from working with, especially these last couple days with the word problems, when you have zeros, what occurs halfway between them? The maximum or the minimum. Well, that maximum or minimum lies within what's called that axis of symmetry, how they are folded in amongst themselves. Well, if you look at just this one quick rough sketch there, everybody sees how it's up like a cup, which means what was your first term, positive or negative? Positive. Your A value was positive, as well as you had a couple of zeros, so you had real solutions. Well, what we're going to be able to do here, not only are we going to be going up and down, but we're going to take them internal. We're going to take internal. Instead of having an x squared parabola, we'll have y squared parabolas. Okay? So we're going to walk through a bunch of a few of these things as we go on over the course of the next week or so. So what you guys are all accustomed to seeing for graphing quadratics is what they call standard form. And that is your y equals ax squared plus bx plus c. You guys are all accustomed to seeing standard form. That's how you guys were taught to work with quadratics. From that, you learned about the quadratic formula, complete and square, and all that. But what's nice about standard form, in order to graph something out of standard form, you can take some of those coefficients to make ends meet, if you will. For example, if I write out, where's my here? I'm not using graph paper. I'm rough sketching. I have 3 different types of formulas to work with, and I'll have 3 examples today. First one is our standard form. Like I said, it's your y equals ax squared plus bx plus c. Now, yes, this will be the time that I would take your calculators away from you, because you can put in your calculator in a table and go from there. So if and when we have quizzes or tests and things on this, I'm not going to keep the calculator away from you to the point where you can't multiply and solve some stuff. I'll give you the dumb calculators, the ones that can't graph. Okay? So if you can't multiply 3 times 2 in your head, you'll be okay. When we go to graph these things, since we know that these guys are all parabolas, there's a few things that you have to show. When I look at that, we know what direction it's going. Up. We know that this is going to be up like a cup. Therefore, I know that somewhere within it, there's going to be what we call an axis of symmetry. Now, when vertical lines are drawn, what's the equation of every single vertical line? X equals anything. X equals a number. X equals a number is always the equation for a vertical line, whereas y equals a number is always your horizontal line. So you guys vaguely remember that from algebra? Okay. Now, what we're going to do here is when we get something that's in standard form, the very first thing you do is you're going to find, move this up, you're going to find the axis of symmetry. And the axis of symmetry is always found by this very generic formula. X equals the opposite of b divided by 2a. Okay. So in our example here, we have 2x squared minus 8x plus 6. So what's the opposite of b here? 8, good. So our example gives us 8 over 2 times 2, otherwise known as 2. Very good. So here comes the fun part. Like I said, no graph paper. I don't care. Looks like an axis to me. XY grid there. Yep. X equals 2. Make a vertical line. Axis of symmetry is usually drawn with dotted lines, just so you guys know if you're looking at that. There's my axis of symmetry. That means I know that the parabola itself is going to fold in on that spot. It's going to be able to spin over on each spot. But with that axis of symmetry, there's always going to lie one very, very important special point. The vertex, the maximum or the minimum. Now in this case, we know this is going to be up like a cup, so we call that its minimum. It's up because it's a low point. So we know that there's going to be some low point here. Well, in order for us to find our vertex, what's the x-coordinate going to have to be at the vertex here? 2. Because your vertex is always on your axis of symmetry. Whether it's an up like a cup, down like a front, or eventually returning left and right. Their axis of symmetry will be a y equals a number. So the vertex will always be on that. So I know right off the top that the vertex is going to have an ordered pair at 2, comma, something. Yes, sir?
Don't we just plug in x?
Are you doing electrical work?
No.
No.
You said plug in.
Oh.
Substitute.
Okay.
And yes, you are right. All you have to do is substitute in 2 for x. And you'll notice that most of the times these numbers are so easy, you don't have to do anything besides using your head. What you're doing to figure out what y is you take 2 times 2 squared, subtract 8 times 2, and add 6. What's 2 squared?
4.
Times 2.
8.
8 minus 16.
-8.
Plus 6.
-2.
Where's your axis? Where's your vertex then?
-2.
2 negative 2 is what you meant to say, right?
Yeah. I just thought you meant like the y.
So now I have a place to put my vertex. I go back to my graph. I mark off -2, and there it is. You told me where it is. I placed it. I know this has got to go up like a cup. So now what I want to do is find what are called symmetric twins. We talked, I think, a little bit about what that meant. When you looked at your word problems and we had those zeros where they're coming down like that, these 2 points would be equidistant to that axis of symmetry. In other words, they're called symmetric twins. They're the same distance apart. If you folded one from here onto the other, they would just be the same thing. So what we do is we pick really, really ridiculously easy numbers to work with. Like I said, you don't have a table function. What's a really, really, really easy number to work with for x?
0.
0. Here's the reason why I'm saying that. If I choose 0 for my x value, what do I get for y? 6. See how easy that was? So I have an ordered pair at 0 and 6. How far away is 0 from the axis of symmetry? 2. What's 2 more to the other side? 4. So that means at 4, it has to be 6. I'm using my brain. I'm not using my calculator. Yes, ma'am?
So the whole point of this is just to get a general sketch of it, not to find zeros or anything?
Correct, because we're not finding zeros specifically this method.
Okay.
Okay? How far away is that?
Oh, right.
And then this would be the same amount on the other side. So I know it's going to look like that. Yes, sir?
Are you going to add complicated fractions to this?
Of course, but when you look at it with the numerical, as long as you pick numbers that make sense, it's not that bad.
I know, I'm talking about like graphic fractions.
If it was 1/2 x squared minus 3/4 x plus 2, what am I still going to use for x?
0.
Okay, so does it matter?
No.
Right. It doesn't matter. You're going to use your brain here. You're going to use your brain to find numbers that make sense. I've heard that once or twice before. All right. What? Yes. Maybe. I'll explain it in a minute. Okay. So when you're working with something that's in standard form, basically what you're looking to do, and you do this the same time every time you have standard form, first thing you do is you get the axis of symmetry by the x equals the opposite of b over 2a. Find the vertex, and then symmetric twins. Okay. So the only things you got to plot with that, axis of symmetry, vertex, a set of symmetric twins, and you're good to go. The other method is a new method. The other method is something new. It's called vertex form. Okay? Vertex form looks a little bit different. Vertex form. I'm going to reintroduce you guys to H's and K's. I'll explain it in 1 second. Vertex form is nothing more than y equals, this out. Vertex form is y equals a times the quantity x minus h, quantity squared, plus k, where h and k are your vertex. Therefore, the axis of symmetry goes through H. What's nice about stuff that's in vertex form, you know everything right off the bat. If your A value is positive, it's up. If A value is negative, it's down. Just like the other stuff. This vertex that we're looking at, if I happen to have, I'm going to use the smartboard here because I put it up here. If I give you a formula that looks like this, y equals 2 times the quantity x minus 2, quantity squared minus 3. Let's say that's my equation. It's in what they call vertex form. They're giving you what's an h and a k. You guys have actually worked with h's and k's before, not knowing you were working with h's and k's. Do you remember this formula?
I remember H's and K's.
Remember that? Point slope? Point slope form is a linear version of an h and k shift. H is a horizontal shift. It's how it's being moved left and right, your x value. K is a vertical shift. It's moving up and down. I know. It's easy to remember. H, horizontal, left and right. K, vertical, up and down. You're moving things left and right. You did this with lines. Instead of going to the origin, you moved it over a little bit and moved it up, where you had different y-intercepts. That's what that meant. You just didn't know that's what you were doing. Now, in this case here, I have this x squared minus, or x minus 2 quantity squared. What's my h value? 2. Is it 2 or is it going to be negative 2? It's going to be 2. The h value comes right out of here. So if it was x plus 2, it would have been good. Now, does the k value change signs though?
Yes.
No. K value is always the same sign. The h value is the opposite sign. It's weird how they write these things. Once you get a couple of them, you'll be like, oh, all right. So I know that my h is 2 and my k is negative 3. Therefore, where's my vertex? 2, negative 3. Where's my axis of symmetry? What is 2? Good. You're already 2/3 of the way done graphing that problem. The A value again was what? It's 2, and it's positive, right? Therefore, it's going to be going up or down? It's going to be moving up. So let's pick very easy numbers to work with.
0.
0. What's 0 minus 2? What's negative 2 squared?
4.
What's 4 times 2?
8.
What's 8 minus 3?
5.
Okay, that was hard. There's 5. What's up?
I have no idea, but
What I just did?
yeah.
Okay. What I'm doing here is at this point, you understand, you know how it's
finding
moving.
the 0 and the.
I'm not-
and stuff.
Okay, I'm not finding zeros here. I'm
Not,
not,
sorry, not zeros, but
The
the
next-
planes on the 0.
oh, all I'm doing is just picking a number that's easy to work with. I'm picking a value of x to get y. So what I did here is we chose 0, because 0 is always easy to work with. And I'm figuring out that y is going to equal 2 times 0 minus 2, 20 squared minus 3, and that equals 5. Remember when you first learned how to graph lines? You guys made tables? You picked a couple of... Oh. You picked a couple of numbers that are easy to work with? It's the same idea. I'm substituting in 0 to figure out, for x, to figure out what y is.
I just, when you started doing it, I didn't realize you put 0 into x, and I had no idea where you were getting the numbers, so all good.
Okay. You can always, and it doesn't always have to be 0, because sometimes your axis of symmetry might be at, negative 33, which means you might want to use negative 32 or something along those lines. It really depends upon the problem. Whatever's easy to work with, okay? So again, we noticed that at 0 became 5, right? So our first set of ordered pairs would be at 0, 5. And what's the symmetric twin to that?
2.
Well, 2, 5 would be on the axis of symmetry. 4, 5, good. There you are. What we're doing here is winding up to pick numbers that make your lives easier to work with. Okay. Now, I know you were worrying about fractions. Sometimes you might get something in here where it's, let's say it's 1/2 out front. If that's the case, what would I want this to wind up being? What type of a number? Even. Good. I want that thing in brackets to wind up being even. Because what's half of an even number? Something without a decimal. If it was a 1/3, I want it to become a multiple of 3, along those lines. Just to make it easier to work with.
I have another
So you
question.
just
Yes,
want
sir.
Is there any way to, so I can see exactly where I'm going to make my problem. I'm going to make h negative when it's supposed to be positive and positive when it's supposed to be negative. Is there any way to remind me of that?
Opposite of H,
Okay.
same K, opposite H, same K. There's really no mnemonic thing that I can come up with. It's what, the more you see, well, what I want you to remember is that this might be the first time you've seen an H and a K. By the 5th time you see H and a K with all the different types of equations we use, it's going to be old hat. It's usually the first round that you just get used to it. All right. Not terrible, is it? Okay. The last one is the easiest because you've been using it already. The last one is called intercept form. The last one's called intercept form. And this is where you're graphing via the zeros. Yeah, and you've done that. We did that with all those different types of word problems. We found your zeros, you plotted it, got the axis of symmetry, which wound up 9 times out of 10, we were looking at our maximums. You've used this method without knowing that's what it was called. So the intercept form is when you have y equals some value a times the x minus p, x minus q. These p's and q's are your zeros. You're finding your zeros. So if it was x minus 3, your zero would be at 3. If it was x plus 6, your zero would be at negative 6. That's where you're getting that from. You've done that. You've found zeros before. That value a out front just means if it's positive, it's up. If it's negative, it's down. Some of the times that we've worked with those intercept forms, the problems that we were working with in the word problems, remember we had one where it was it 1,000 minus, or was it plus 200x? We worked with it just like that. What this is saying to do is to factor out the GCF. We just didn't do that. That's the only difference. Okay, that's the only difference. The problems that you're going to see will look like this. Let's see, what was it, negative? Yes, oops. When do you graph this using the intercept form? See how it's already given to you written out with zeros? So we're going to graph y equals, when it just says negative, what's next to that negative you just don't see?
1.
Good. It's negative 1 times x plus 2 times x minus 4. Where are your zeros? Negative 2 and 4. Everybody okay with that?
Yeah.
Good. So when we start this out, we know that we have zeros at negative 2 and positive 4. What lies halfway between them? 1. The axis of symmetry. And we've been saying this all along because we did that with our word problems. Go ahead. That's the A value again. That A value is just telling you this is just going to be down in the crown. We don't have to distribute because I'm not multiplying all of it out. Okay? I'm not worried about it. When it's given to me in this form, this is just there to be there. We're not worried about distributing that. You're still going to wipe with the zeros that work through. Yes, ma'am?
How do you find the axis of symmetry?
I'm glad you asked. What's negative 2 plus 4? What's after that?
1.
There it is. Huh?
How does that work?
Because these are, notice how these two are on the same horizontal line?
Right.
These two are their own symmetric twins. So they're equidistant to that midpoint. Okay? So I know that my axis of symmetry is at x equals 1. So where's my vertex going to be? Well, at 1 comma something. What do we do to find something? No more electrical work.
Substitute it.
Thank you. So, one thing that people tend to forget is that the A value, when it's just a negative symbol, means it's negative 1 times. So just write it out, negative 1 times 1 plus 2, 1 minus 4. Negative 1 times 3 times negative 3 gives you how much? Positive 9. And it's moving down like a frown. So when you're working with intercept form, it's always the easiest. They're giving you your symmetric twins to start with, and the axis of symmetry is just the midpoint of the zeros. And it works every time. Okay? Yes, sir?
So you can't plug in substitute 0 for x.
You can if you want, but it's not going to. It doesn't matter because you already have one set of symmetric twins. You got to find that vertex. That vertex can align the axis of symmetry. So when you're in intercept form, the two things you got to get is the axis of symmetry and vertex. Or the other ones, you had to find the axis of symmetry and the vertex, and then a set of twins. Whereas you're given the twins to start. It's just a quick one. Yeah.
So, can we talk about why we did those problems?
Yeah. Let me give you homework first. Yes, ma'am.
So with the intercept form, your x, when you like plug it into, when you substitute it into your intercept like equation,
Yeah.
it's always going to be like whatever your axis of symmetry is.
Yep. Yes, ma'am.
When we take like quizzes and tests, will we get to choose them or will you make us do one of like each one of them? Or do we get to do one?
It'll be I'll tell you what to use. Okay. And as we get into this a little bit further, there's other twists that'll happen eventually, but we're not there yet. This is on page 253. I'm gonna have you do 3 of each of them.
I love this.
Next week, we'll do a little bit more of the algebra that throws into here. And then we'll start messing around with how you can graph them. Instead of being an x squared, which was up and down, a y squared, which goes left and right. Okay. All right, give those a shot. The reason why you guys were doing those